Hey everyone, it's good to have you back. Hope you're all doing well. And this time I have decided to make something called the Game of Life in MATLAB. The Game of Life is John Conway's simple yet very popular algorithm to create cellular automata. This algorithm is originally applied on infinite two-dimensional orthogonal grid of logical values. However, since we do not have unlimited memory, we will need to use a substitution in a form of torus grid, looking like this. And the algorithm consists of a set of simple rules that represents the cellular interactions. These would be the rules. And the two challenges we will be facing here are the definition of the initial conditions and the implementation of the algorithm itself. So let's get it started. Now once again we will need to define the 8th neighborhood to search on the map, and since we have done that before in our wavefront video, we can just copy and paste this part into our new Game of Life algorithm, just like that. Next we will need to define our map. So first we will have x-axis, let's say 800, and y-axis 600, and our map will consist first empty, so zeros, and the amount of rows will be y and columns x. Right, just like this. Okay. We shall also need a map where we shall record our next step of the algorithm, so we shall make it our initial map in this step. So now, to define the initial conditions, the funny thing is there are no preset rules as to what this should look like, so I will just make it some random noise in a for cycle, just like so. We'll go as far as we need in order to reach all the elements on the map. Now to create the random noise searching through the map, we shall give the map an 8% chance to create a logical value of 1 instead of remaining 0. So we shall make a comparison just like this. And once the 8% chance hit, we shall make our map on this position logical value of 1. There. Now as for the algorithm itself, in a for cycle, let's say we can have 100 steps. Within it we shall search in x-axis, then in the y-axis as well, just like so. And when we start searching through the map, we shall set the amount of our neighbors 0, and we shall be looking for how many neighbors a certain point has, and we shall do so by searching through the neighborhood we have defined before. So just like so. and searching through the neighborhood we will get new positions for x and y axis, just like so. Yeah, so both for x and y. Now, in order to move in a torus grid, we shall need to check on which position on the map we are, and if we are out of the map, we will need to reposition our new position elsewhere. So let's do it first for the x-axis, and if our new position is less than 1, which means out of map, we shall make it not 1 but the very other side of the map. Also, if it is more than x, we shall set it to 0. We should be setting the value over here, of course. So we have done this for x, and we will do so for y as well. Just like so. Once this is done, we will ask if the cell on that position is alive or dead. So our new positions, however, starting with y, just like so. We shall increase the amount of neighbors by 1. There. And now as for the algorithm itself, once we have the amount of neighbors, after this cycle is done, we shall implement the conditions from the game of life. So these conditions will suffice. If the amount of neighbors equals 3, we shall make the cell alive. So our map on the next step and on the position in the cycle equals 1. And also, if the amount of neighbors is less than 2, or if the amount of neighbors is more than 3, which means overcrowding, the cell becomes dead, so it will be set to 0, just like so. And this really should be it. However, once all this is done, our map shall become the map on the next step, and also we shall show the map on screen. However, we should not be setting the new positions to 0 but to 1, because 0 is still out of the map. Now we should be ready to see how the algorithm works. And as you can hopefully see, many different shapes are appearing on the screen, simulating cellular interactions in an automated way. Now we can make many different shapes, and that's really dependent on the initial conditions. I will show you some of my favorite. Now I've got a pre-made game of life algorithm over here, and this one I call the star explosion. It takes a lot of cycles until it oscillates. So let's just take a look at that. And if they interact, like over here, they can cancel each other or do many different shapes as well. And that should be it. So this concludes the game of life algorithm. I hope you guys like it. Let me know if you have tried and what you think of it. And I hope to see you again another time.